Hi, good morning. I was told there was a natural hush over the room as I was doing some work in my office, so I probably should come in and break up the hush. Good morning, my name is Dean Garfield, and I have the privilege of working for almost 60 of the most dynamic and innovative companies in the world as the president, and Chris Hansen, who is very influential in organizing this event, as president and CEO of the Information Technology Industry Council. I'm stunned, I tell you, that there are this many people in the room on a Thursday before Labor Day weekend. I think we probably represent nearly 90% of the folks who are working in Washington this week. And I hear there are lots of folks watching the web stream as well. So thank you for being a part of this event. Hopefully, my expectation is that we will not disappoint at all. I suspect that many of you will be leaving this event or watching the event as well and heading out for Labor Day. To your chagrin and mine, you will not be alone on the roads. As AAA has shared, nearly 85% of the 35 million people who will be traveling this weekend will be doing so by car. That's a lot of people on the road, but even more fossil fuels. In any given year, and I was stunned to learn this yesterday, we use almost 170 billion gallons, that's right, billions with a B, gallons of gas on the roads through our vehicles. That will take you about 3 trillion miles or 1,000 trips to Pluto. And so today's panel is really about how ICT and intelligent transportation together can reduce the number of trips we take to Pluto. In fact, I told the team yesterday that by the end of this event, the Pluto project will be trending on Twitter because I'll have said it so often. We've got a great lineup of folks to talk about how the combination of intelligent transportation and ICT will drive the reduction in fossil fuels, lead to greater sustainability and greater safety. Today, the emphasis is on sustainability. We'll start off our discussion with Scott Belcher, who is the CEO and president of the Intelligent Transportation Society of America, or ITS America, as most people know it, as well as with Anthony Shaw, who's the author of the report that I drew that statistic from. I was telling Anthony earlier that it's an incredibly well-written report. There are lots of reports that get put together in Washington. This is one that is worth not just putting on your shelf, but actually reading. And so do pick it up and read it. After Scott and Anthony share with us a little bit about the report, we'll then have a great panel that will talk more about the issues that have developed there. And before we do that, I'll introduce the panelists. Their bios are in the materials that you were given or that you walked past in the back. And so I'll forego the bios just so that we can get to the interesting conversation that I'm sure all of you are interested in. If you are watching via the web stream, then you can present your questions. We'll have a session for question and answers at the end through ITIF DC. And if you are chatting about this on Twitter, I was trying to think of the right verb, but then the hashtag is connected cars. All right. My role is largely done, and so I'll turn it over to the folks who actually have something intelligent to say about intelligent transportation, starting with Scott. Thanks, Scott.
Thanks, Steve. Well, good morning. I'm thrilled to be here. This is a topic that's very personal to me, and part of the reason that I'm here at the Intelligent Transportation Society of America. Technology has the opportunity to really transform transportation, and it is actively transforming transportation, and it also has the ability to really drive down the impact that we have on the environment. And we haven't yet taken full advantage of that opportunity, and so it's studies like this, it's work like we're doing with Caltrans and MTC about what other ways that emission reductions can be used to help California achieve its emission reduction obligations. It's this kind of work that really matters. So I'd like to thank the Digital Energy and Sustainability Solution Campaign for their sponsorship and active collaboration. Thank you, Chris. I'd also like to thank our partners the Information Technology Industry Council, Dean, Information Technology and Innovation Foundation, and the Center for Clean Energy, Energy Innovation, as well as our distinguished panelists. Their collaboration in advancing high-tech technology, transportation solutions, and highlighting the transformative impact smart technology can have on reducing fuel consumption and transportation-related CO2 emissions. This is very important. Actually, let me go off script a minute, because I think what's really important right now is we're facing, or we're entering into a new period in transportation history. And I really think it's an exciting period, and I think we're at the precipice of something that we haven't seen really ever in our generation, the people in this room's generation. And what's really driving this is this confluence of traditional legacy transportation players that have been invested in the system for a very long time, and then new players from the ICT industry that have different ways of looking at the world, different ways of approaching risk, different ways of approaching reward. And that's created a tension. It has not, and an uneasy tension, but it's also created opportunities that we've never seen before. And it's this tension, it's this collaboration that is changing transportation more quickly than we've ever seen. It's making the legacy players act differently than they've acted before, because there's a sense of urgency. We are emitting far too much emissions from the transportation sector. The automobile manufacturers are being squeezed with CAFE standards. There's a limit to what they can do from a technology standpoint. So they're very interested in alternatives. States, the country have got very real challenges that they have to meet, and there's a limit to what they can do. And so this tension, this collaboration, I think is creating great new opportunities for us, and will create the most exciting period in transportation history. And as I say to my members, you should be scared, because some of you aren't going to have jobs, because we're changing in real time one of the major industrial verticals in this country, and I'm excited about it. If you think about it, the average person spends nearly a full week stuck in congestion. Full week of their life stuck in congestion every year. That's 2.9 billion gallons of fuel. It costs the economy more than $121 billion. That's significant. That's significant. And if you think about what it does to the economy, about not being able to move people and goods in an efficient way, and what that does to it, it continues to move us down the rank of effective national economies. And we need to change that. If we want to continue to be innovative, and we want to continue to really lead the world, we're going to need to have a transportation system that works and that's sustainable. In 2011, traffic congestion resulted in an additional 56 billion pounds of carbon dioxide. That's in addition to whatever emissions are caused by cars that are operating in not in congestion or on rural roads. And we have technologies today that can make a huge difference. Electronic tolling, weigh-in-motion truck inspections. Let me just tell you an anecdote about weigh-in truck motion. When I took over this job, I met with the CEO of a company that deploys weigh-in-motion technology all across the nation. And I sat with him, and I knew a little bit about heavy-duty vehicles, and I just asked him a few questions. The first question was, so how many trucks get green-lighted? And green-lighted means they would have stopped and had to sit and idle and be weighed. Well, about 50 million. 50 million, these are not closed truck stations, they're open truck stations. Okay, 50 million. They all would have stopped, yeah, 50 million. I said, so how much, and they don't turn off their engines while they wait, do they? Oh no, we never do that. Okay, so, and what's the average time that a truck sits and waits? Well, 15 to 20 minutes. And how much diesel fuel does a truck burn in 15 to 20 minutes? About a half a gallon of diesel fuel. And I said, so you're telling me that this technology is saving 25 million gallons of diesel fuel and the related emissions? He said, I've never done the math. So we just did it. And you think about that. You think about what electronic tolling. We all used to stop at toll facilities and wait, and drop in our coins. Now you drive through toll facilities. Think about what the emissions associated with that are. We've got in the study that we talked about. Now, let me just be clear about the study that Anthony's done. There's not a whole lot of studies out there about technology right now in transportation. And so our goal with DESK was to get a little bit of data on the table. It's not, it's not perfect and it's not complete, but it gives you some good examples where we've actually captured data in some case studies and can look at those and gives you some examples of what can actually work and the impact that we're having. And that's pretty exciting. It's to be able to begin to quantify the emissions associated with. We've got a fair amount of data around reduction in congestion of different technologies. But for those of you in the environmental community, you know that the environmental community and the transportation community often don't talk the same language, and so reduction in congestion doesn't necessarily translate into reduction in emissions in a very clean way. And so we need to start to build data and data sets that the environmental community is just as comfortable with as the transportation community is. And this is a beginning of a broader process that we need to go forward to do this. We have a tremendous opportunity to harness these innovations and these technology to make a real difference and to reduce the U.S. oil consumption in this country and to reduce the emissions associated with that. I mean, for example, wireless applications like vehicle platooning can reduce our oil consumption by millions and millions of gallons a year. And as Congress moves forward with a long-term transportation bill, we need to make sure that we help them factor in the use of technology not only to make our system more efficient, not only to make our system safe, but to make our system much more sustainable. And we have that opportunity, unfortunately. We don't have a long-term bill. I'm optimistic we'll have a long-term bill in the next 5 years. But we will have a long-term bill at some point. And I think, so you can look at the world as the glass is half full or half empty. Let's look at it as half full. We've got a little bit more time to work with Congress and help them factor in sustainability. And the great thing about this discussion with Congress is this is a win-win. People love this stuff. I mean, it's not political. You can't go, well, I don't really think that smart parking works. It does work, and I don't really think I want to incentivize it because that's what the Democrats want. But it's not a Democrat or a Republican thing. So we've got an opportunity to really educate Congress and really help in this next reauthorization. So let's make sure we take that opportunity. Let's take studies like this, and there will be more studies that will come out over the coming years, especially as this administration embraces sustainability and climate change in its own way. Hopefully that can give us more data that we need to work with Congress. And so without further delay, let me introduce Anthony Shaw, who's a technical program specialist at ITS America, and he was a principal author of this report. And Dean, he's a very good analyst, but he's going to stay at ITS America.
We couldn't afford him anyway.
Thank you, Scott. Good morning, everyone. My name is Anthony Shaw with the Intelligent Transportation Side of America. I'd like to thank DESK and ITI for hosting us and our distinguished panelists for joining us today. With the support of DESK, ITS America undertook a study to investigate some of the potential sustainability benefits of intelligent transportation systems. And that's what we'll present today. So to figure out how to make this work. All right. So the goals of the report. Our main goal was to provide an objective way to compare environmental benefits of a broad range of transportation technologies. Research reports that are out there, they kind of often talk about the benefits in terms of a % reduction in a generally a strictly defined research study area. So hypothetically, a 15% reduction in some geographically constrained study. We wonder, what does that mean for a local city, a state, a region, on a national scale? We found that there's really no way to compare apples to apples out there in the literature. So we sought to address this by demonstrating the benefits, the fuel consumption benefits, and the carbon dioxide emission savings benefits. So we kind of went through the literature, normalized a lot of the results, and demonstrated them on 2 measures. Finally, the final goal of this report was to illustrate these technologies in action, in actual real-life deployments. Because if you read about technology, it can kind of seem, kind of esoteric. And what we sought to do is kind of fix that, bring that to life. We covered 16. Try this. 16 transportation technologies, so a pretty broad range. Divided them up into 4 categories. First category is vehicle technologies, so things you would find installed in your vehicle from the manufacturer. Traveler information technologies, so things that can help you get through your commute. Infrastructure and system operations technologies, such as signal control, incident management, and finally, alternative fuel technologies. So for our projections, we looked at 2 measures. Carbon dioxide emission savings, which is the major greenhouse gas emitted by the U.S. transportation sector, and fuel consumption. And as it works out, if you do one, you kind of do the other. So we did this on 2 scales, and we looked at the magnitude of the potential benefits, the first order benefits, in terms of both a single vehicle, so what does this mean for one car, and on a national scale, so what does this mean broadly speaking for the U.S. transportation sector. And then we went forward and projected these benefits out for a period of 10 years, which is slightly shorter than the lifespan of an average vehicle on the road today. So some of the results, the magnitude of these first order benefits on the order of millions of barrels of oil for each technology and per year, and on the order of millions of metric tons of carbon dioxide emission savings. For instance, some highlights: eco-navigation, which is a way to get you through your commute, not based on shortest travel distance or shortest travel time, but least fuel consumed. Could save on the order of 100 million barrels of oil per year and about 18 million metric tons of carbon dioxide, and this is for the final year of our 10-year projection. Another highlight is the potential savings that gas-electric hybrids could have. They could save about 400 million barrels of oil when compared to the same size fleet of average, internal combustion engine vehicles. And that translates to over 30 million metric tons of carbon dioxide, again, in the final year of our projections. One of the other main results of our work is that we now have a kind of modular toolkit that you can tailor to reach a certain audience. So you can make this case either for fuel consumption, or if you have a different audience, you can talk about carbon dioxide emission savings, depending on interests. Finally, we have this model and the software that we use to build it that can be updated as new data become available. Something I didn't put in the presentation, but which is available in the electronic version of the report, is a series of kind of graphical visualizations that we think can communicate the national scale benefits quite well. So I encourage you to take a look. So we'll go through a couple examples. There we go.
Yeah,
Technology.
I'll take it.
Thank you. One example is cooperative adaptive cruise control.
Tech part of the partnership.
Yeah, you need some help sometimes.
We'll see how I do.
How it works is you don't need a clicker. It's based on available technology like adaptive cruise control, which uses a radar to kind of slow your vehicle down if there's a car in front of you. Building on that, cooperative adaptive cruise control uses wireless vehicle-to-vehicle communications technology, so that the lead vehicle, which in our study is a heavy-duty kind of commercial vehicle, takes control of the longitudinal and latitudinal motion, so the forward and back, left and right movement of the vehicles that follow it. You can create a very tightly grouped platoon of vehicles, which improves efficiency of not just the following vehicles, but as the lead vehicle as well. And it does this by significantly reducing aerodynamic drag on the highway. So some magnitude of first order benefits.
I've been practicing.
So a leading, the leading vehicle, which in our case is a heavy-duty vehicle, just one vehicle can save about 1,400 pounds of carbon dioxide emissions per year. And the following vehicles, which in our study were your average light-duty passenger car, can save about 140 pounds of carbon dioxide per year. Some of the conclusions from this example would be that when you're comparing adaptive cruise control as it is available now to cooperative adaptive cruise control, which is being tested on the highway, this wireless connectivity and the automation that it introduces can triple the efficiency. Moreover, this application, which is kind of a safety mobility application as it is designed, turns out to have significant environmental benefits. And finally, the recent regulatory activity from the United States Department of Transportation shows that the government is behind this and is actively moving forward in developing the communications technology that underlies this kind of application.
They can see it at the World Congress, can't they?
They can. That was my next point, actually. We worked very hard on this presentation, and there will be a demonstration at the ITS World Congress in Detroit next month. The other example I want to point out, because we have the professor here from Carnegie Mellon, is real-time adaptive signal control, which in our study is an enhancement on previously existing adaptive systems, and that it is actual real-time using actual traffic counts with video detectors, loop detectors, radar, sensors at each intersection. And this is unique in that it optimizes a signal timing plan for each intersection once per second in terms of the amount of time that a car has to wait at that intersection. This uses a concept from robotics that I'll let Professor Smith explain a little more fully. But it also informs all the downstream intersections of the traffic conditions and what's going on at that intersection. So it reduces the environmental impact of congestion at a traffic signal by getting rid of some of that wait time. So the time you're spent idling, burning gas, not going anywhere, it optimizes that signal timing plan to get rid of some of that downtime. So some of the magnitude of the first order benefits that we found is about 2 million metric tons per year of carbon dioxide. And this is applicable, I should say, on kind of urban areas. So if you're from DC, think like Thomas Circle. That's the kind of place that it would work best in. Some of the conclusions, again, this is a mobility application that improves travel time through a congested area, but it turns out to have tremendous environmental benefits as well. And this is also something that's being currently deployed, so we can point to kind of a real world deployment of this. So instead of kind of this pie in the sky idea of new technologies, this thing is actually out there. And finally, the final section of the report are these 4 use cases that we use to illustrate the benefits of transportation technologies. We have 4 of them here. Traffic signal synchronization, which isn't necessarily a new technology, but as it is applied in Los Angeles County, has tremendous benefits because it it lines up all the green lights on kind of major arterial corridors, allowing kind of a higher throughput through that corridor, and again, reducing wait time. As I mentioned earlier, real-time adaptive signal control in Pittsburgh, advanced fleet management at the Smithsonian, which their fleet of vehicles, they installed telematics and wireless tracking and management of their vehicles, allowed them to reduce the size of their fleet, reduce maintenance costs, reduce fuel costs. And finally, smart parking in Ellicott City, Maryland. And there's a number of examples of this around the country, just like adaptive fleet management. But in this instance, the company that built this system for Ellicott City has both analytics for the city parking managers, as well as for people who are in the area trying to find a parking spot. And we thought that was worth highlighting. These 4 use cases are available in the full version report. And our next slide, and on our conclusion slide, we've seen tremendous first order benefits of these technologies if applied on a national scale. We've created a modular toolkit that can be tailored to your audience, help communicate these benefits to the public, and as a kind of a living document that can be updated over time as new data become available. We've seen mobility and safety applications that also have tremendous environmental benefits, and I think that's an argument that needs to be made more often. And finally, we've given the recent regulatory activity from the United States Department of Transportation, especially a recent advanced notice of proposed rulemaking about vehicle-to-vehicle communications technologies for safety. The government is actively supporting the underlying technology that can make some of these savings possible. And the report is now available online. And I'll turn it over to Dean.
Thanks. Thank you. Great job. I'm now convinced we have 110% of the working population of DC in this room. I think there is one free chair up here if you're standing and would like
There are a few chairs.
And would like to sit down. As I mentioned at the beginning, actually, before we transition to the panel, Scott, you've given the best example or motivation that I've heard thus far for transitioning to EasyPass, which is the sustainability benefits. I now feel like a Luddite since I'm still throwing coins into those things, but I'm going to immediately go out and get one so I can help do my part for the environment. 2 other announcements I made at the beginning. If you have questions, we're going to turn to questions after the panelists make opening statements, then present them through ITIFDC. And if you're tweeting about this, the hashtag is ConnectedCars. So we've got a great panel who will get us started in the conversation. We'll start with Steve Smith. Yes, that's Steve Smith from Carnegie Mellon University. Then we'll turn to Catherine McCullough from the Connected Car Coalition. We'll then continue with Matthew Stepp from the Center for Clean Energy Innovation. And then Jill Agracia from AAA will round it out. And then we'll have a bit of a conversation and take your questions. Steve, do you want to get us rolling?
How's this?
I think we're good.
Yeah. Oh, it's on.
You can bring it closer.
Great. So I'm happy to be here. I'm a technologist, so I feel a little bit out of place, but I'll just make a couple brief points in the opening statement. And my research group has been working in real-time adaptive signal control for urban environments in particular for the past 4 or 5 years. It's not my long-term background, but I now know quite a bit about it as we've gotten into this problem. We've, by bringing some concepts from other work that we've done in the area of scheduling and robotics, we've been able to develop an approach that I think for the first time really allows real-time adjustment of traffic in urban environments. Urban environments are hard because there is not always a clear dominating main flow, but rather there are lots of conflicting flows that change through the day. So if you can adapt to the traffic flows in real time, you can move traffic much more efficiently. So the approach that we've taken, I'll just say a couple words about it. We take a decentralized approach, and that has a couple of advantages, but the idea here is that each intersection controls its own local traffic. So each intersection watches the traffic that's approaching through some kind of detection, cameras, radars, loops, and then based on incoming flows, essentially builds a timing schedule for how much green is going to get allocated to each approaching segment to allow all vehicles to move through in the most efficient kind of way. The innovation, this is not the first time this has been tried, but the innovation now is that with more modern kind of solving techniques, you can now do this orders of magnitude faster than you could before. And so we have a formulation that allows us to solve this problem in a sub-second time. So we can really be real time. So each intersection operates independently, builds a plan for servicing the traffic it sees, and then it communicates the plans to its downstream neighbors. Downstream neighbors are doing the same thing, but now they have a larger horizon of what's coming down the pipe behind what they can see, and that's how coordinated activity occurs. So there's a little more to it than that, but that's basically the concept. We were honestly, sustainability wasn't our first motivation when we started thinking about this problem. We were thinking more generally about congestion, relieving congestion, which obviously has a related effect. But in fact, when we went to try to demonstrate this in the field, try it out, we went to a local foundation who was principally interested in improving quality of air. So that was really the motivation for trying it. We tried initially on a 9-intersection network in East Liberty region of Pittsburgh. This was in June 2012 timeframe. We did a formal performance evaluation, and we got really good results. We were doing sort of before and after comparisons at different periods of the day. The kind of rolled up numbers say that we reduced fuel consumption and by implication emissions by 21% in that 9-intersection network. We improved travel times, average travel times to the network by 25%, reduced wait times by over 40%. So the point in those statistics there is that the vehicles aren't really moving faster, but they're stopping less time. And stopping less means they're idling less, and so on and so on. So that's an important point, particularly in urban environments where you have significant pedestrian traffic and other kinds of flows of traffic. And in fact, our current work is really aimed at sort of better integrating pedestrian flows into the mix. And it turns out you can do that with little compromise to the others, the other kind of flows. In November, the foundation, the Heinz Endowments, who funded the work, were really enthused by the results. They subsequently are funding expansion. In November of last year, we went operational with 9 additional intersections, sort of growing the network, I guess, to the east around a new high-tech area in East Liberty. We did a similar comparable study in November last year, and we got nearly identical results, this time assuming that the original 9 were just on as a baseline condition and what additional improvement you got flowing through the extended network under that condition. So we sort of have these sort of two consecutive examples of kind of benchmarking the kind of improvement you can expect. We're currently we're now actually undergoing a much larger expansion. We've both east and west from this additional site. So by mid next year, we expect to be running a network of 50 intersections. And so, there's a lot of enthusiasm in Pittsburgh. We're also looking downtown. The largest portion of that expansion that we're doing now, construction is proceeding on the putting in the detection, is that we're also installing DRC designated shortwave communication radios at 24 of these intersections along 2 of the corridors, moving to an adjacent neighborhood, Oakland. That brings me to my second point, is that with the kind of onslaught and the advent and onslaught of connected vehicle technology, the potential for impact is even greater here. I mean, from the vehicle to infrastructure side, you're going to get much better sensing capability if by direct radio communication with the vehicles. So being able to more accurately detect vehicles is going to automatically give you a better opportunity to further improve traffic flows. But it also, sort of going the opposite direction, gives you the opportunity to think about to provide or integrate route choice kind of information into the traffic signal flow optimization. So if I detect an incident or a particular kind of congestion in one area, I can the infrastructure can communicate and take into account the fact that, well, so many vehicles that I suggest go this way will actually go that way, and sort of think about that larger optimization problem of rerouting some amount of vehicles to further alleviate. So there's opportunities for even bigger impact as connected vehicles and eventually automated vehicles come on to sort of further smooth that. The last point I would make is that the implementation of real-time adaptive technologies like SureTrack, which is the name of our system, but is not necessarily as expensive as one might think. If you look out into urban environments now, you see a lot of conventional signal systems that are already sort of optimized and synchronized, and in that you also see a large number of intersections, and increasing all the time, that have simple actuation that basically can recognize you when you're sitting at a stop sign on a side street, and if nobody else is there, it'll pick you up and service you. Those are very basic kinds of adaptive, but those are pretty commonplace. So in many cases, you have the infrastructure in place for adaptive, and you can think of putting in the adaptive control as just an add-on to that. So well, I'm just thinking of the Pittsburgh example. For example, whenever the city buys or upgrades a new intersection, they put detection on it now. So that's part of the mix. So in general, it may not be as expensive. With a decentralized system like ours, or like SureTrack, and you can also grow networks incrementally. You can see this in the expansion that we're doing now, but you can kind of pace installation, deployment of this kind of technology to the funding streams that you have and are able to get. And just finally, then, I mean, Pittsburgh, I think we've been able to take a lot of advantage of the generosity of various foundations in Pittsburgh that are interested in really improving traffic flow in the Pittsburgh region. But as we've sort of moved on and gotten bigger, we have now been starting to engage in more public-private kinds of cooperation. UPMC, the medical I don't know what you call it, conglomerate. No, I don't mean it in a bad way. I couldn't think of the word. They are actually funding a a large part of the construction of this big 2-corridor extension that we're involved with now. It moves right through a hospital and research conflict facilities of theirs, and from their standpoint, it helps them to sort of manage the flow of traffic in the region of there. We've started talking with folks downtown, and there seems to be some receptiveness to the big stakeholders downtown, which are a different group, but some of the bigger landholders downtown that of the advantages that they could get out of sort of putting money into it. So that methodologically, that's one possible, or promising, I think, way of looking at pushing this kind of technology forward.
Thanks, Steve.
Sorry it took so long.
No problem. You did well. Catherine?
Hi, my name is Catherine McCullough, and I'm the Executive Director of the Intelligent Car Coalition. And we're a group of companies that are working together to advocate for and to evangelize on intelligent car and connected car technologies. And one of the things I'm actually most often asked after people kind of dance around it for a little bit is, what do you mean when you're talking about a connected car technology? And I can understand some confusion. I mean, the word is used pretty interchangeably for quite a few classes of technology. Some people throw autonomous in there, some people throw B2B in there, some people are talking about connecting to the internet. The way I think about it is that these technologies are technologies, kind of a whole host of technologies that are being brought along in the ICT space and in the transportation space, which, as Scott mentioned, is merging. And these technologies all work to connect you to the road by more than just your hands on the steering wheel. So whether it's through an OBD port, whether it's through your phone, whether it's through some V2I, DSRC spectrum, you're going to be far more connected to your travel experience than you have been in the past. I'll tell you a couple other characteristics of these technologies that I think are common to both. First of all, I think that in pretty much every case I can make, and these are, by the way, all great examples that you give. I'm really glad that you did concrete examples. I think it really helps to kind of put people's minds around it. But in all those cases, and in other cases with connected car technologies, I think a lot of what happens is we are given better information by which to make better decisions. So if you're talking about navigation, if you're talking about car diagnostics, if you're talking about finding a parking location, the information that you're gathering to get people flowing through traffic better, all of these technologies are essentially optimizing information in order to direct you toward a better result. And that kind of brings up a second part for me that makes these technologies distinct. The way I see it, these technologies are different even than other terrific technologies that we have, the internet, our smartphones, all these wonderful advances that we have, which are enabling so much for us as individuals. These connected car technologies have group benefits through individual incentive. And here's what I mean by that. So for a time I worked on the Hill. I worked for the Senate Commerce Committee, and we had transportation under our jurisdiction, part of it, and we had communication under our jurisdiction, and some other areas under our jurisdiction. And I can tell you, when you're in a position to be giving your thoughts about a policy matter, it can be a little bit frustrating, because often whoever's talking to you has their finger pointed to a real problem. You'd like to come up with a real solution, but often there are limitations on what you can do. You can, for instance, Congress could pass a law. You can write a new law about something. An agency could write a regulation about something, or there might be a third way to take care of some kind of societal issue that you might want to come up with. Congress, as you know, is having a bit of a difficult time passing laws right now. So it's, that has become, a pretty difficult avenue by which to solve policy issues. agencies, when they make regulations, are restricted by their statutory infrastructures. There is only so much they can do. And frankly, when you're talking about technology, which moves very quickly, it cycles very quickly, it changes very quickly, and also can change, frankly, to solve its own, a lot of its own policy challenges. You know, an agency regulation may not be appropriate to put on top of a new technology. So what you have in the case of connected cars, I would argue, is something in the third category, which is you have created, through all of these terrific means, individual incentives that add up to a societal benefit. I would love to go to Ellicott City and use the parking app and be able to find my parking space faster, and get into the Ramshead pub. I think that it's a terrific example of so many things that are coming to market. And in this case, not because anybody mandated it, but because consumers want this. They want safer roads. They want fuel efficiency. They want to save money. They want, they want to reduce carbon emissions. They want to make sure that their car is running efficiently. I think it is very notable that a lot of the progress on these technologies was led by the commercial side through trucking, for instance, because that's where they see the incentives right away. It goes right into the owner's pocket if they're able to make routes more efficient, reduce fuel costs, et cetera, et cetera. And I think you're going to begin to see an expansion of this on the consumer side as awareness of these technologies spread and as awareness of their benefits spread. And then, of course, the more people who use them, even though they may be using them for some kind of individual incentive and individual benefit, I think that all of us in our society are going to benefit through reduced carbon emissions, reduced traffic, and frankly, safer roads. So.
Thanks, Catherine.
Good morning. Matthew Stepp. I'm the Executive Director of the Center for Clean Energy Innovation. And not only are these 16 technologies that Anthony talked about considered clean technologies, but really the critical reason why I focus on these type of technologies, focus on intelligent transportation innovations, is that they're a core way that we're going to solve global climate change. It's the core mission of CCEI, and when you think about it, transportation is a third of U.S. carbon emissions, and they're one of the fastest growing sources of carbon dioxide globally as many developing countries start to reach kind of middle class livelihoods. Folks want what we have and what Europe has and wants to be able to drive and move around, and right now doing so means burning gasoline. So these type of technologies are critical in transitioning to low carbon. And the innovation side of this, I think, is important because at the end of the day, innovation is going to be what addresses climate change. Innovations that we developed in the past decades are what are being deployed today to reduce emissions, and innovations made today and in the future, in the coming decades, are going to be what deeply decarbonize the global economy by the end of this century. And so smarter ICT-based and low-carbon fuel technologies are really what's going to transition transportation to a low-carbon future. And I think why this report's important is that it finally puts some numbers to that. It's kind of a first of its kind in that sense. So what I want to do briefly is put the report into context, what we mean, what these sustainable benefits are, and then talk a little bit about innovation policy. And the context here is important because if you go through the report, you can't add up all of the carbon dioxide and oil reduction numbers. They're not necessarily additive. Some of the technologies overlap. They address similar issues. But depending on how you add them up, what the report's talking about is about a 2 to 4% reduction in oil consumption over the next 10 years. And that seems like a pretty small number. It's a kind of metaphorical drop in the oil bucket, right? But I think that's not necessarily the main story here. I think the main story is how we can accelerate this process. Because if you go through the assumptions of the analysis, and rightfully so, many of these technologies are still emerging. Many of these are still in lab testing. Some of these are available but not being deployed. And many of them are only in niche markets. So we're only kind of at the infancy of ICT-based transportation technologies. And so there's a kind of a key line that Anthony put in the report that he's assuming kind of a slow and steady growth in these technologies over time. And in number sense, what he means is about a 5% increase in penetration for these technologies. And is that a big number? Is that a small number? Is that something we can work with? So to give it comparative sake, the National Renewable Energy Laboratory did a transportation energy future study, and they found that for most new technologies for light-duty vehicles, the average penetration rate is between 1 and 24%. On the low side, typically, is alternative fuels. Things like hybrid vehicles are penetrating about 3% growth per year. But individual technologies, energy efficient, engine efficiency, drivetrain, those type of things tend to be on the higher side. So I think 5% falls more on the conservative side of growth. But also, NREL points out that when you're looking at these more rapidly growing, rapidly penetrating technologies, that's typically because there's a good mixture of innovation, cost reductions, and some sort of government policy that's driving that deployment. And so it gives I think the report gives a really solid foundation that all else equals, status quo, not much going on. These technologies, because they're beneficial, because they reduce costs and they have environmental benefits, are going to deploy at some slow and steady rate. And so I think it's up to innovation policy to a degree to rapidly deploy them if we're going to use these to solve climate change in any meaningful way in the coming decades. So I'm not going to go into kind of a very long list of policies, but a couple of broad topics, maybe we can talk more about it in the Q&A, is how do we move from 2 to 4% reductions to double, triple, move that forward into the future so it actually has a meaningful impact. And the NREL study, I think, rightly points out CAFE standards as one of the major drivers of engine efficiency, and CAFE standards are a big incentive of new technologies. Problem is that when you're looking at a lot of these ICT-based technologies, they're not necessarily applicable to CAFE standards. How do you do lighting optimization with CAFE standards? It doesn't necessarily sync. So I think we need to start thinking about what's the equivalent of CAFE standards for municipalities across the country to deploy these new infrastructure-based technologies. Are there different regulatory pathways for doing so? Are there new incentives for doing so? And I think that's a kind of a new conversation we can start to have. I don't know if it's clear we can tie them to CAFE standards. Maybe we can, but maybe something new is needed. I think another piece of this is regional and local pilot and demonstration projects. We're doing some of these. Anthony and Professor Smith talked about some of these demonstration projects and their locations. We need to be doing more of that. We're talking about the surface transportation bill. I think this is a good opportunity to do more and more of that. And the idea there is to get local governments comfortable with these technologies. But I think the side benefit is also these demonstration projects can start to sync the auto industry and the ICT industry, who don't speak the same language and work on different schedules, innovation schedules and development schedules. Start to sync those two things together. So we're not necessarily waiting decades for new technologies to deploy. We can cut that in half or cut that down. Another common one is government procurement. Any issue dealing with climate change, government procurement's a solution. But I think we need to be heading into a space where no government is procuring fossil fuel-based or dumb technologies in the transportation space. I think a good argument can be made that all these governments can cut costs and have environmental benefits by procuring these technologies. The case studies in the report point that out. So working through, some of that has happened through the stimulus program and the Green Cars initiatives, but I think more of that needs to be done, particularly at a state and regional level. And then the other piece here is electric cars. Traditionally, when we're talking about transportation and climate change, electric cars is the technology. The report rightfully points out that it represents the biggest carbon reduction, because you're taking out the fossil fuel portion of that equation. But we all know electric vehicles are inhibited in deployment by their batteries. There's a cost and range anxiety issue. So a lot of that potential penetration growth comes down to that. The EPA assumes by 2016 that electric vehicles are going to be penetrating about 6%, increasing to about 15% by 2025. And the only way they assume that those numbers will hit is with rapid reductions in cost and increase in range for those vehicles, and that means innovation. I think there's a strong argument to be made that traditional lithium batteries aren't going to be what gets us to that point. A significant amount of money is going into R&D for new batteries, technologies, new chemistries. More should be done to kind of quickly transition those new ideas into some sort of pilot and demonstration so we can test these things out really rapidly in the marketplace. So I think in conclusion, I think the report shows that these smart technologies can play a small role given nothing else going on, but it's a kind of a small and steady role growing over time. Policy can easily make these technologies a big player in reducing emissions, and that's what we want. They should play that role, and they can, and they will. But much more work needs to be done. I think there's a lot of pragmatic, innovation-based policies that can get us there. Thank you.
Thanks, Matt. Jill, bring us home.
All right.
A lot of burden and responsibility on your shoulders.
I know. I will try to keep it brief. I suspect most of you are familiar with AAA, but for those of you who may not be, AAA is a federation of motor clubs, and we serve over 54 million members in the United States and Canada. We were founded over 112 years ago to advocate for safety, mobility, and safer roads, and that remains a core element of our mission today. The other panelists have done a really great job outlining the innovation that's occurring in the transportation sector, so I won't cover any of that. As a member organization, I tended to look through the report with a consumer lens, or through a consumer lens, so that's where I'll focus most of my comments. You've already heard that we announced our Labor Day holiday travel forecast last week and estimated that 35 million people will be traveling at least 50 miles or more this Labor Day holiday weekend, and 29.7 million of those travelers, or approximately 86%, will get to their destination by car. That is an increase of 1.4% over 2013 and represents the second highest share of travel by auto since 2003. And the high watermark for auto share of Labor Day holiday travel was in 2009, when it was as high as 91%. So the story that tells me is that there's still a robust desire for travel by car. And consumers care a lot about gas prices. They've watched the national average price of unleaded regular gasoline steadily decline over the recent weeks and months, which has been a good trend from their perspective. Today's average is $3.43 a gallon, but despite this trend downward, if we know anything, it's that fluctuation in gas prices is something we can count on. So consumers are really still interested in reducing their costs at the pump. So the thing that I think is wonderful about the great news in this report is the technologies described here are, to use Scott's term, a win-win opportunity for motorists and our national sustainability goals. The fact that we could be reducing fuel consumption and reducing emissions in a non-punitive way, not asking drivers to sacrifice their planned vacations or to change their daily commutes or to pay premiums at the pump, I think is wonderful. Investment in these kinds of technologies will save consumers both time and money, and at the same time improving mobility and allowing for the safe and efficient use of our existing transportation system. The numbers cited in the report are impressive, and I think they're going to be important for the national policy discussions. For the average consumer, I think the smaller pocketbook quality of life statistics and messages are going to be what resonates. We can tell them that you're going to have to fuel up less, fewer stops at the gas pump. That's going to save them money. Less time snarled in traffic means more time to spend with your family, your friends, doing your hobbies, whatever you like to do. And more predictable travel times means less daily frustration. So we're very supportive of these kinds of initiatives that can reduce fuel consumption and improve air quality, and very encouraged by the numbers that were shown in the report. In terms of how we get there, I think obviously there's going to be different strategies required for different audiences. I think the numbers cited in the report are going to be an effective tool to use as I said, in discussing the potential impact at a very high level, for example, in the context of the transportation bill. And I share Scott's optimism that in the next 5 years we may have a transportation bill. And getting a multi-year fully funded transportation bill is a top priority for AAA. And despite those gloomy prospects, we're also on record supporting an increase in the federal gas tax to provide some near-term funding stability going forward. I think public education and awareness is going to play a critical role in public acceptance and adoption of some of these technologies where we need public buy-in. Pilot projects, I think, are a good way to expose the public to new and innovative solutions. And I think importantly, to the extent that you can measure the impact and report the impact of those pilots, that's important as well. So from AAA's perspective, pursuing our sustainability goals, we think it's important that passenger, motorist safety, consumer choice, and mobility aren't impacted, and this report provides great examples of how you can do that. So I will stop there.
Excellent. All right, we're talking about innovation and disruption.
So I'm going to do something pretty disruptive, which is assume that you're smarter than I am and start the questions with you rather than with me. If you don't carry out that responsibility well, I'll just take over and ask all the questions. I'll actually start with, sorry, it's a half-truth. I'll start with a question from online, which happens to come from a reporter, Paul Kirby from TR Daily. For the panelists, any of you, how concerned are you that the DSRC spectrum reserved for connected vehicle applications will experience interference from unlicensed vehicles? Scott, do you want to? Oh, sorry. I'll just speak louder. You can have that back.
So why don't I start with that? I think we're very concerned. I think it's important. So just for those of you who are not familiar, the connected vehicle program that USDOT has moved forward with in advance notice of proposed rulemaking are vehicles that communicate with each other on a part of this Wi-Fi spectrum, 5.9 gigahertz spectrum. ITS America and AASHTO, the organization that represents the state DOTs, is a licensee for that spectrum for the connected vehicle program. When we did that, when we licensed it for this program, but at that point the spectrum wasn't incredibly valuable. Now it's very valuable because it gives folks the ability to send a lot of data over a short period of short distance of space. So the ability to stream video in the back of your car, for example. We at ITS America are completely. We agree with sharing of the spectrum, but we're absolutely committed to making sure that before a decision to share the spectrum is made, we know that that sharing will not put lives at risk. And so there needs to be a sharing proposal. It needs to be tested, and it needs to be demonstrated that that will not put lives at risk. And so we're going to continue to advocate to the FCC and to Capitol Hill to make sure that we do it right and that we don't get ourselves into trouble. We are a little bit concerned that there's a lot of political pressure to move to a sharing solution before this happens. And we all need to be vigilant to make sure that that doesn't happen. We all need to be vigilant that we use this spectrum quickly because it's important spectrum, and we want to make sure that we're advancing the ball. So,
great.
Anybody else?
I guess the only thing that I'll add is that we agree with what Scott said, which is obviously representing the tech sector. We have an interest in this issue as well. Are also committed to seeing that spectrum shared. We all know the value of unlicensed if you're using Wi-Fi or any of those other services. It would be silly for us to suggest we're not concerned about your safety as well, and so want to make sure that testing is done and done well, but also done expeditiously. All right, additional questions. We'll start in the back.
Primarily for Dr. Smith, my name is Mark Carr, I'm with Channel Design Group. How much more does it cost to wire an intersection, if that's the unit of measure, than what the municipalities are already doing? Because you said they were already installing some things already. So are we talking about $100, $100,000? What are we talking about per intersection?
To put in adaptive technology?
Yeah.
Well, that's going to vary, I guess, with respect to different different kinds of technologies. They may have their own kind of pricing things, but clear of detection maybe on the order of 15, 20K.
And then we'll come to the front.
My name is Skip Leitner, a resource economist and fellow with American Council for an Energy Efficient Economy. Two numbers come to mind. I wonder why these were not framed in the study. Very good study. I really love what I hear. Number one is the U.S. economy is perhaps at best 14% energy efficient, and transportation is even less than that on average. Number two, when we total up the gasoline bill in the country, it's on the order of $600 to $700 billion a year, and that does not include lost productivity, it does not include the lost time, the congestion, does not include health effects. And yet none of the economic perspectives were brought forward in this, which is critical if we're going to be talking long-term sustainability, which implies that we need to move from a 14% efficient economy on average to perhaps 5 times better than that. And yet none of these were there. Huge steps forward in implementing. I'm wondering if you're going to bring these issues, these perspectives out in future studies, or why they were not looked at in this particular example.
Sure. So initially, if you can hear me, I think that's a good point, and that's great context for the report. And I appreciate you bringing those numbers out. I think it really helps define the magnitude of the problem. Like I said initially, this wasn't intended to really be a long-form report. It turned out that way, and I think what we've done is provide a baseline, a conservative baseline of the first order benefits. And I think what's really necessary here is kind of a longer term analysis of this problem on a national scale, and I think this is the first step forward in that.
Skip,
Thank you.
Chris Hankin, I'm the executive director of DESK, which was the funder of the study, and I just basically just to build on that. As the funder, we didn't have a lot of money, and yet our conversation with Scott and with his team was we need to start getting the numbers out there. So let's start with something as a first step. Let's start something that we think from gets the conversation going, but also using a methodology that'll make it easy to build on. And with the hope then that others will be interested in the conversation in the study and in funding. So with the idea that perhaps even the federal government could help fund building on it and bringing in some of the needed further evaluation that you're citing, Skip. So it's basically, we actually agree with you, but with the idea that this was the first step and let's build on and bring in those others.
Skip, I don't know you, but I'll go by your first name since Chris used it. Both you and Jill raise a good point, though, about how do we talk about these issues in a way that capture consumer interest. And a part of that is not just large numbers, but the narrative that is sufficiently compelling that will motivate them to help us create a movement. So I made a joke at the beginning about the amount of gas that we use is enough to take us to Pluto 1,000 times a year, and the idea of a Pluto project. But how do we come up with something that's sufficiently compelling so that people can grab onto it and tweet about it and then act on it?
Well, if I might,
I think we shouldn't leave that behind.
Good comment. The National Transportation Operations Coalition, of which I think ITS America is a member, in 2007 put out a study that said there are about 300,000 traffic signal systems in the U.S., and if we retrofitted along the lines that you're talking about, it might cost on the order of $10 to $12 per household, but it might save $50 to $100 more on avoided gasoline costs for the very reasons that you're alleging. So there is a basis for this already.
Right. Front row.
Yes, Steve, I'm Brock Mix. I'm executive editor of Atlantic Media. I just wanted to know how much traffic you're actually moving through these intersections. I mean, it's very different if it's out in the burbs or if it's downtown.
Yeah. I think I'm trying to remember a little under 30,000 vehicles a day.
Another
Very
question
good
in front.
answers. Very
Just
precise.
happened to remember that.
That's good. I like that.
Art Gazzetti with the American Public Transportation Association, and I commend the report for bringing data and numbers to something that's potentially transformational, both a mobility point of view and from social point of view. My question is on the report's titled "Connected Cars," but Catherine pointed out sometimes a lot gets folded into this autonomous cars. So, to what degree was this report done specifically with connected cars in mind, rather than by inference the broader question of, say, autonomous cars? Because I in my mind I see a distinction there, and especially when we're into the quantifying the say environmental issues there. Anyway.
Certainly, I think sometimes connected cars and autonomous cars get mixed together. Some of the autonomous vehicle prototypes that are out there use vehicle-to-vehicle communications in their prototypes. Some don't. But there is, I think, important use for vehicle-to-vehicle connectivity for autonomous driving. Unfortunately, there's not a lot of studies of the environmental benefits of an autonomous vehicle. So we looked at it, but nothing that I found actually quantify that in a way that we could use. I think you would see something similar. I mean, we looked at cooperative adaptive cruise control, which is a form of automation. Some of the following vehicles in such a platoon would give up the longitudinal and latitudinal control to the lead vehicle, which is somewhat akin to autonomous driving, but not exactly. But I think you might see some of the same benefits on the highway. In an urban area, it depends on how you program the acceleration and deceleration curves for.
Anthony, is that concept being deployed anywhere? It seemed.
There's a lot of work in Europe as well as in the United States. I think.
And when I say that concept, I meant the lead vehicle in the platoon travel pattern.
Where what needs to be developed is some more research into like the interaction with the platoon for other vehicles before it can be deployed, as well as who's going to actually be the driver of the lead vehicle. I think there's some ideas in Europe to have a licensed like driver, but there's a lot of research going into it in the United States as well.
Oh, so the concept is like a pace car moving the traffic.
In a way, yeah.
So two comments, Dean. One is.
Can you guys hear us, by the way, in the back? Yeah, you're good.
So one is this technology will be demonstrated at the ITS World Congress in Detroit in September 7th through the 11th.
I'll be there.
And second, the state of Texas is creating a freight corridor where they'll be deploying this technology and showcasing this technology. So it is starting to be deployed in this country.
Great. Nancy, I'm sorry, Catherine, I saw you leaning forward. Did you want to ask that?
No.
Okay. Right here in the black shirt.
Hi, Spencer Schecht, with a graduate student at American University and volunteer at Citizens Climate Lobby. This Mars thing, I think most people can do right now to avoid congestion is to stare at Apple Maps while they're driving. It really isn't that safe. But I think a lot of people kind of guess that these technologies are already out there. So how do we create that convincing narrative that it not only saves time, it's going to save you money, it's going to save lives because we have cleaner air, and that we're going to have smarter 21st century cities instead of using traffic lights that we've been using for the last 100 years.
And if it's integrated in the car, like heads up, then you won't get in an accident because you won't be looking at your device.
Yeah, I think I can take that one. I think there are three main connected car, if you will, technologies coming down the road in the next 6 to 10 months that are going to show the consumer exactly what it means to be connected. And they aren't all necessarily directly aimed for the environmental benefits, but I think it will really help with adoption of entire systems that also include environmental benefits. So you mentioned Apple. Apple and Google both have car interfaces that are going to be showing up in cars. I believe Google's is still scheduled by the end of this year, and Apple's is early next. These interfaces are going to look a lot, I think, like versions of your phone. interface, and there will probably be a set number of apps on them. Probably maps, maybe parking, maybe some kind of tolling, who knows. And I think that through this kind of use, people will begin to learn about what's possible, just as they do today with their smartphones. I mean, I'm sure that 95% of what I have learned to use today in terms of technology, I've learned from my friends, or from my younger cousins. So it's certainly, I think it's going to be something that kind of spreads virally once it gets out there. So I think you have, the Apple CarPlay, it's called. You have the Google interface that's also going to be coming in, and then AT&T and GM have actually just started introducing a certain kind of connectivity in their cars into, I believe, 30 types of vehicles, where essentially you can bring a whole bunch of devices into the car, and you can, download to your heart's content and have the kids watching, different movies in the back with their own devices. I think that's going to begin to bring home, hey, there's something larger that can happen in the car here, to quite a lot of families. I think it's, and then as that occurs, I think people are going to begin to see their car as a place for more than travel, but also for other solutions that include, reducing carbon emissions, reducing the amount of gas that you buy, and increasing efficiency.
So can I just comment?
No, you cannot.
So I think it's important not just to focus on cars. Because we're part of the transformation that we're going through right now is called shared use mobility. I don't know if any of you are familiar with Ride Scout or Ride Panda. These are two great applications that are the beginning of kind of this new movement. And what they do is they're a consolidator of applications. And so you can use one of these applications to determine what your transportation options are. So you don't have to drive. You can share a car, you can share a ride, you can share a bike, you can use transit. You can find out how long the transit's going to take, how long the walk is, how much it's going to cost. You can make informed decisions. So we're going through another transformation that is separate from the car, and it's all about shared use mobility. And it's a generational change as well, and it's a technology-based change. And so I think as we think about this, there's a ton of stuff that's going to happen with vehicles. There's no question about it. It's going to get better, more sophisticated, more interesting. You have better options. But I think it's just as important to think about what your options are in terms of transportation. Because particularly in our urban areas, we're going to be moving more and more towards shared use mobility. And as we move to autonomous vehicles and connected vehicles, you're moving to new use situations there too. And you're moving to new infrastructures. And so this connectivity, this new other ways of thinking about how we move around and how we get around are really important.
Jill.
I think that's important comments from Scott, but I do want to go just back to the car issue, and the thought of having most drivers on the road staring at maps while they're driving is scary, very scary to me. So I think I would be remiss if I didn't at least just remind everyone of the importance of safety. And we're bringing all kinds of new technology into vehicles, and we need to think about making them as design them to not be distracting, and we need to think about how all of this technology changes how humans interact with their vehicles and what the implications are for that. So safety always needs to be sort of a top priority for all of this.
And if I may add to that, the technology is coming on board to enable that. Mm-hmm. I alluded to heads up, but there are so many other technologies that will alert you or even stop your car in spite of your desires to ensure that you don't create an accident.
There's some great stuff. There's heads up. There's voice. Right. There's technologies that track where your eye movement is, so that they know if it's wandering. It's terrific.
My car the other day told me I was drowsy, and I had a little coffee signal, even though I don't drink coffee. come back to the audience. We're going to go for about 10 more minutes, but we haven't talked about policy and how that may affect accelerating the deployment of these technologies. Just wonder your thinking on the kinds of policies that are needed to do what Matt suggested, which is accelerating deployment of these technologies. Don't all jump in at once.
I'll go. I think that there are several policy-related things that need to happen. First of all, as we talked about, there needs to be pro-innovation policy, and that can certainly, mean a lot of things at a lot of different times. But in general, I would say that we need to make sure that we are incentivizing investment in innovation, and make sure that we are keeping in mind that when innovations lead to a greater good, it makes a lot of sense for the government to get behind that. I also think, we talked a bit about spectrum. We need good spectrum policy, and not just on the DSRC. We need it, up in the levels where these roam, because there's going to be a lot of the ecosystem is, maybe on your phone or maybe on something else. There are, lots of different bands of spectrum, and, I don't, suppose that any of them are going to get ignored by innovators who think that they have a solution that can ride on one of them. So we need to have adaptable, appropriate spectrum policy to allow innovations to happen. I would also say the same of data policy. We need, data to flow in an appropriate manner to get some of these societal benefits going. And I would say, generally, one of the first things that we don't need is for, I would say, infighting among policymakers to get in the way of anything that is possible. So, it would be, I think, a real shame to see, and keep in mind I work out of that, so I'm sure I'm just as guilty of this in the past as anybody, but to see committees fighting over jurisdiction, to see agencies fighting over jurisdiction, to have some kind of procedural, drawn out process instead of focusing on the issues, because we're getting so many of the benefits that so many of us have worked so hard for. And it's so important. I mean, when we're talking about climate change, we're talking about saving people's lives on the roads. I mean, you don't get higher stakes than that.
One or two? Jane, go first.
James, thanks. Mr. Shaw mentioned there's a lot of work in this area in Europe, and of course there's a lot of work in Japan and in Asia. Can we assume that everybody's going to follow the U.S. lead, or do we have to worry about the interoperability of different national systems, i.e. the two-plug problem? Was that some things like that slow down deployments?
So that's a great question, particularly in, let's start with connected vehicles. The three regions of the world are in fact coordinating and collaborating on a 5.9 or a close spectrum to that, so that the automobile industry doesn't have to create different vehicles for different regions. So there's a lot of collaboration in that space. As we're moving forward with autonomous vehicles, there's a greater move for greater collaboration there. Standards, set on a regional basis, are being trying to be moved through the ITU and through some of the other ISO and some of the other international standard-setting bodies. So the motivation is there. Whether it happens or not is a very different question, because we all want interoperable standards as long as there are standards. But we are trying to work on that, because it does have a significant financial impact, particularly for the automobile manufacturers.
Hi, I'm Dick Munch from Compass Transportation and Technology. I thought it's interesting that most of your options are focused on the vehicle rather than the public sector. And that's good, because the public sector has a long history of not spending all they should on ITS. If you're a true believer in autonomous vehicles, you may get to be more than the 2 to 4% savings. Most of the autonomous vehicle savings will come through reduced congestion, which has productivity gains but huge environmental gains. Have you looked at the congestion impacts of the 16 examples that you looked at? Because that would be a way to start to get some of these things up.
Are you asking about the autonomous vehicles? And
No, I'm not. No.
Oh.
Okay, if you said yes, I'd love to hear it. But I doubt that. They're looking at the ones you looked at. Have you looked at things beyond environment? Looked at the congestion impacts.
Well, they're obviously closely related. The scope of this report was just on the environmental emissions and fuel consumption. So we looked at that on a per mile or a per incident or per circumstance kind of ratio. It would be one of the things is that there's this balance between higher efficiency and savings there and increased demand. So that balance we try to keep in mind as well. And incidentally, that's something that'll affect the environmental impacts of, as well as the congestion impacts of new technologies like autonomous vehicles. So as these things become, as you see individual drivers see benefits, in their gas tank and in their wallets, how much is that going to make, how much is that going to increase their demand for travel? That's something that we have to keep in mind, I think, when we talk about this.
All right, oh, come on. I'm a softie. This will be the last question.
Sean Fitzgerald, Booz Allen. I'm all for the innovation policy. I think it's a beautiful thing, more technology, but a lot of the people I talk to in my work, they say, so what? If I have to pay $10 more or $10 less over a year, so what? Is there any kind of policy kind of the new age, kind of the psyche kind of policy being thought of? I mean, cafe standards were great. They were punishing people for doing bad things, getting people in line, but there needs to be something more for the huge portion of our population that doesn't really care about technology. I mean, for example, like in Arizona, where they said, oh, you're going to get a tax credit if you get an electric car. Didn't do anything. But then you said they could go in the high occupancy lane and save 50 minutes, going to work, and suddenly they sold out in a month. Mm-hmm. So these new policies that weren't tried before, is there more focus on that rather than the old school ways?
I think that's a great question.
Actually, while you're answering that, we got one more question online that's related. If you can discuss that in the context not only of your personal vehicle, but in the context of public transportation as well, that would be helpful.
Yeah. I think that's a really good point. And, as any policymaker will tell you, probably the hardest thing to get around is is human nature. I think, you can sit there and legislate all day, but humans are what they are, and they're going to incentivize to do certain things. To me, the answer, I think, is that there will be many answers. And that in the same way that there will still be many modes of transportation, public transportation, automobiles, and there will be many solutions attached to each of those modes of transportation, I think that the most successful policies are going to be the ones that create the most incentives for folks to adopt the technologies and use them. And I think to begin that, I think you need really good innovation policy, because innovation policy allows a whole bunch of different technologies to pop up. It allows people to experiment and figure out what they like best. It allows a policymaker to figure out, where the crowd is moving and how far they can go just based on, what's out there. And I think that that's a very good way to start. If there's a hole in then what's in the marketplace, maybe that's a time to take another look at it. But I think that it is time for maybe a more flexible culture where we think, hey, I really want to get to a solution here, maybe a little bit less about I want this one method to a solution. I think we're talking about quite a few solutions in this new era.
All right, you've been a great audience. Have a great Labor Day weekend. Thanks for being here.